Okay, so we're going to do a little projectile motion tutorial here, and I'm going to do that by going over a couple of questions from our physics textbook, which is page 543. We're doing numbers 9 and 10. So we'll set the stage for you in case you don't have a textbook. Number 9 says, while hiking in the wilderness, you come to the top of a cliff that is 60 meters high. So we've got our 60-meter height cliff here. You throw a stone from the cliff, giving it an initial velocity of 21 meters per second, and that is angled 35 degrees above the horizontal. The question wants to know how far from the base of the cliff does the stone land. So this stone is going to take a parabolic path, and it's going to come over here somewhere, and this unknown space is where we want to find out how far does it go. So we call the range the distance that a projectile travels, so we're looking for the range travel here. Okay, so to get that range, we're going to need to know how long was it in the air. So we need to know the time it takes to smack into the ground over here. To get that time, we're going to have to break down our initial speed of 21 meters per second into a x component and to get a y component. So that'll be a crucial part at the beginning of this to get Vx and Vy. So we're going to use some simple trigonometry. The x component of the speed is the v times the cosine of 35, v cos theta. So 21 meters per second times the cosine of 35. And Vy is going to be 21 meters per second times the sine of 35 degrees. So when we plug those guys in to our calculator, we will get, we'll move this out of the way, so 21 times cos 35 gives us 17.2, so 17.2 meters per second. And if we do 21 sine 35, 21 sine 35 gives us, I hit enter, 12.0 meters per second. Okay, so we've got our Vx and our Vy. So we know how fast it's moving in the x direction and how fast it's moving in the y direction. So now, how are we going to figure out the time that it's in the air for? All right, so what I'm going to set up is I know what the height is at this point. At the point it hits the ground, I know my height is 60 meters below where it started. It is down here. It just happens to be way over there. So the height is negative 60 meters. So my formula for height is it's VIY, the initial y speed, t plus 1/2 g t squared. That comes from the formula that says the distance is VIT plus 1/2 AT squared, where we're using G for A and VIY for VI and the Y distance. Okay, so that's where that formula comes from. All right, so my height is negative 60. My VIY was 12. T plus 1/2 negative 9.81 meters per second squared times time squared. So we've got ourselves a quadratic to deal with. Negative 60 equals 12t. 1/2 of negative 9.81 is negative 4.905 t squared. I would take everything in this quadratic to that side and make it a positive. So you have 4.905 t squared minus 12t, subtract 60 equals 0. That's a quadratic that your grade 11 math class can solve. So what you would do is you would call the 4.905 is term A, negative 12 you'd call B, negative 60 you'd call C. You plug that into the quadratic formula, negative b plus or minus square root of b squared minus 4ac all over 2a. When you plug all those numbers in, you will get two answers for time. Since this video isn't about solving quadratic equations, I'll just tell you what the two times you get are when you plug those numbers in. You get one answer of negative, let's put the negative on there, negative 2.48 seconds, and the other time is 4.93 seconds. So the negative 2.48, all that signifies is if this was launched from the ground at negative time, how long before it was launched. So that's the negative one. It doesn't pertain to us at all. So we don't want the negative in this situation. So the 4.93 is the time we want. That's how long it was in the air. So if you know how long it was in the air, you can use that time because that's also how long it was moving sideways with the Vx speed of 17.2 meters per second. So we can get our entire range by using the x speed and the time. So speed times time would give us the distance, 17.2 meters per second, and it did that for 4.93 seconds. Multiply those two together and you get a range of 85, when you round it off, 85 meters. That's the x distance or the range. So it travels 85 meters over. Okay, so we didn't have to solve max height or all these other questions. We're just focusing on what it asked for. It asked for how far does it go. Okay, so let's look at question 10. And we'll erase our 85. So in question 10, you have a batter hits a baseball. So the swing of the bat over here. And the ball goes away at 41 meters per second. The angle is 47 degrees to the horizontal. It's a home run, so the ball is caught in the stands by a fan. At the second that it's caught, the vertical component of the velocity, so the instant it's caught, the VF, the final speed, is 11 meters per second, and it's going down, not up. So it's a negative 11 meters per second. How high is the fan above the ground at that instant? So at the instant that your speed is 11 meters per second downward, what is the height of the fan? Okay, so to solve this question, there's a lot of ways to do it, but I don't want to go and figure out the time it takes for this person to catch the ball there, because I can just answer the question using some initial and final speeds. So I'm, as usual, going to break down my components, my speed, into a Vx and a Vy. And more importantly, in this one, I'm not even going to work out Vx because I just don't care. I don't need it. So we're just going to use the initial Vy. So Vy is 41 times the sine of 47 degrees. So 41 times sine 47 gives you 29.99. So I'm going to safely call that 30 meters per second. Okay, so that is Vyi, the initial y speed. And I know the final y speed is negative 11 meters per second. So we have a formula, the regular acceleration formula. You have one that says that Vf squared is equal to Vi squared plus 2AD. Well, in terms of projectile motion, if we're talking about x's and y's, we can say that the final y velocity squared is the initial y velocity squared plus 2. The acceleration is gravity, and the distance is y. It's the height. It's the position. So if we're going to rearrange that and solve for y, I'm going to take VIY over and subtract. So VFY squared minus VIY squared is equal to 2GY. Then we're going to divide both sides by 2G. And that will leave you with just y. So y, the height, is equal to VYF squared minus VIY squared over 2G. So my final was negative 11 meters per second squared. My initial was 30 meters per second squared. And you divide by 2 times the acceleration of gravity, which is negative 9.81 meters per second squared. I've allowed myself to be very sloppy with units here and not include them. And I get an answer of 39.7 meters for my height for y. So they are about 40 meters above the ground when the ball is caught. Now, what's nice about this formula with the squares is we don't actually know, was this 40 meters when it was on its way down or 40 meters when it was on its way up? The math works out both ways. It's still 40 meters high. It happens to be positive 11 here, and it happens to be going at negative 11 over there. So kind of a neat symmetry to the question. Okay, so there's a great tutorial on how to do two different projectile motion questions when it does not come back to the same height at which it started, which makes these just a little bit trickier.